Okay, we're on lesson 61, question C. Add the two forces to find the resultant force. So here's our picture. We have one force heading this way. We'll call it force 1. 65 newtons, and it's going at an angle of 60 degrees. Relative to this kind of horizontal, arbitrary horizontal line. Okay, then we have a second force coming in here at 65 newtons is the force, the magnitude, and it's also coming in, but it's coming at a different angle. It's 30 degrees, and we can see that it's actually technically negative 30 degrees. It's going down. Okay. So for each force, we're in order to find the resultant force and put these together, we could imagine that there's going to be some, like if these are two billiard balls or something, or the two forces are striking something, they combine. Maybe they're going to combine and kind of go off in that direction. We kind of imagine what direction they're going to go, and we can imagine how much force that will be once the two are combined, but we won't know for sure unless we do the math to add them together. And to add the two forces together, we need to add their components. So remember that a force can be written with two components. F1 might be something, some number times I plus some number times j, and the first number is going to represent the horizontal direction, and the second number is going to represent the vertical direction. So let's see, our red force there, we're going to say it has a horizontal direction and a vertical direction. And we need to figure out what the magnitudes of those individual components are in order to figure out the whole thing. Okay, we basically had formulas here. We said the x direction, x equals the magnitude times the cosine of theta, the angle, and y equals the magnitude times the sine. And if you think about it, any way you draw the triangles here, we've got our angle here is the same as this angle here. The y direction is going to be opposite that angle, and the x direction is going to be adjacent to the angle. So that's how we're going to find our forces. Okay, so we're going to do F1 is the magnitude, which is 65, times the cosine of our angle, 60 degrees, times I. Okay, and that will just stay there. The I will stay there. So 65 times cosine of 60, that's a number, some number. We'll figure it out. And then plus 65, the force, times the sine of theta, j. And again, that j is just going to stay there. And so those would be the two components. Let's go ahead and get our calculator out and try these. So if I remember correctly, we just did this. The cosine of 60 degrees is 1/2. So let's do that. 1/2 times 65. and that's 32.5 I plus the sine of the sine of 60 degrees. Look at that! I put a little theta sign instead of the 60 degrees there in my writing there, but that's you get what I mean. The sine of 60 degrees is going to be that square root of 3 over 2, and the directions told us to just round it to the nearest tenth place, I think. So we're going to do 65 times the sine of 60 degrees, and we'll get 56.29, I'll just say 56.3. 56.3 J. Alright, so there's my first force. I'm going to add that to my second force. Well, let's figure out what the second force is. We did that in green. F2. Now, F2 is different because it's going to go, it has a horizontal. Right, there's the X value. And then it has a vertical, but that one's going down, so it's going to be negative. So there's a couple of different ways we can think about that. Remember I said right at the beginning that was negative 30 degrees. We could just think of it that way. In fact, you can kind of do this on your calculator. So let's see. That's going to be the x direction is going to be the magnitude, which is also 65, times the cosine of the angle, which is 30. Now, you can verify this. Cosine of 30 is 0.866. That's the square root of 3 over 2. The cosine of negative 30 is the same thing. It's 0.86602. This is because the sine of the cosine of 30 degrees and negative 30 degrees are both moving in the positive x direction. So that doesn't really matter. Say I plus, and then the 65 magnitude times the sine. Now here, if I say the sine of 30 degrees, I get 1/2, right? Sine of 30 degrees is the same as the cosine of 60 degrees. If I say the sine of negative 30 degrees, I get negative 1/2. And that's just saying because it's negative 30 degrees going downhill, that means the y component is negative. So I need to put a negative in here somewhere, and then I'll get my answer. Okay, so typing this in my calculator, I just did 65 times the cosine of 30. I say equals, and I get 56.29, which is 56.3, I'll say. I forgot to put my J in there. Okay, and then 65 times the sine of 30, or negative 30, is negative 32.5 J. Now, this is kind of funny. The two are opposites of each other. So, the one force is 32.5 I plus 56.3 J, and the other one is 56.3 I plus negative 32.5 J. Okay, but that makes sense because 30 and 60 are kind of have opposite sines and cosines of each other, so that kind of makes sense. So if I wanted to then add these, F1 plus F2 equals, I just add them together. So 32.5 plus 56.3 is 88.8 I. And 56.3 minus 32.5. Let's see, that's going to be 23.8. And what does that mean? Well, that means that this new vector is going to be going over. We added the x components. It's going to go over farther, but up. The 23.8. That's smaller. It's a smaller distance up than the 60 degree, and it's a smaller distance from the horizontal than the negative 32. So it's the kind of the rise versus the run is going to be quite a bit shallower. So this angle here is going to be smaller. But what we really care about now, we'll come back to that angle. We may be able to we can calculate that angle if we want to. But actually the question didn't say what's the angle. The question said, well, what is this new force? So maybe we'll just call this F3. What is the force there, which would be the magnitude of this vector? And how do we do that? How do we do the magnitude? Well, we just take both components and we square them. 88.8 squared plus 23.8 squared, and then we do the square root. And again, that's no reason not to do that one on the calculator. So pull out my calculator. I'll do the square root of 88.8 squared plus 23.8 squared equals, and it gives me 91.9, approximately 91.9. And that's what we're really looking for. So that's the answer to this question. Notice that the 91.9 is not the sum of 65 plus 65. And that's because the force kind of in the new direction has been muted, right? The part that was going to the right, the part going in this direction, was increased because we added those two together. But the part that was going up was that part was subtracted, and so the new component, the new force lost some of its steam because of the angle that these two are coming at. They kind of dissipated some of the energy going this way and going this way, and got lost in the collision. But okay, that's how we do that. We can figure out the angle. Let's see. We know that the sine of the angle is the opposite. The opposite would be the y component, 23.8 over the hypotenuse, which is the magnitude, 91.9. Or we could do the cosine of our new angle is the x component, 88.8 over the 91.9, the hypotenuse. So we can calculate our new angle if we want to. That's not what the question asked us to do, so we won't do that. Alright, hopefully that was helpful. Thanks for watching.